We are back for the last one for me for this week. 5, I do 5 a week for 4th grade. That's all we're doing this week. So let's wrap up number 5 so we can be done with it. All right. By now, I hope you know I'm Mr. Short. This is Eureka Math Squared, 4th grade module 4, lesson 5. Name, first, last, class number, date. Put it up there. Complete each number bond and equation. Rename the fractions that are equivalent to whole numbers. All right, we're renaming stuff now, but I got you on this one, don't worry. And also, page 33, page 34, I forgot to say it. All right, so we have 15 over 4, okay? So what are we going to add? So we have 15 over 4. We have 12 over 4 here, like it has right here. What are we missing? What is 15 minus 12? Yep, 3 over 4 right here, 3 over 4 right here. So 15 over 14 equals, well, we have 12 over 4 already, and now we have 3 over 4. Okay, but now they want to know what this equals. So now all they're doing is asking you to divide. Don't get worried. They're just asking you to divide. So how many times can 4 go into 15? 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, so we went over. So we got something 4 times 3, which is 12, right? Oh, look, 12. So what's left then? 12 minus 15 is 3 over 4. Okay, that's all it means when it wants you to do it. It's just dividing. And then you show your remainder over what unit of measurement we're using. I need to get closer. All right. Sorry, I should have been a little closer. We got that. We'll do another one together since I was kind of far away. All right. So 11 fifths. We have 1/5 here. So what do we need? What's 11 minus 1? Yep. So put that 10 over 5. All right. Over here, we got to add up to 11. Well, we have the 1/5 here. So put our 10 right there that we just found over here. Down here, same thing. They want the mixed number here to show what this is. Over here, I know we didn't do it. You can do it here if you want. So let's do this one over here. So how many times can 5 go into 10? Because what we're doing is we need to show how many whole numbers we have, right? So divide 10 by 5. What do you get? 5 times 1 is 5. 5 times 2 is 10. So 10 divided by 5 is 2. And then we have our 1/5. So if we put the whole number together to show it as a fraction, you'd have 2 and 1/5. That's what equals 11 fifths. All right. Down here it says, rename each fraction greater than 1 as a mixed number. Use a model to show the decomposition. Well, over here, they did it already for you. So you got to show a model. That means show a picture. That's all it wants you to do. A model is a picture. All right. Rename it and show it. You can do more than one model if you want. As long as the models are in twelfths, that's fine. Over here, the models could be in eighths. Some of the models are going to be full. 5 of these will be full. How many will be full over here? All right, this one you have to show twelfths in your models. So work that out. Here, we'll do this one real quick. So you know what? It's in twelfths. There's not an easy shape to get 12. I'm going to do rectangles because I can do 6. So I got 1, 2, 3, 4, 5, 6. Draw a line, that's twelfths. So I got to have 5 of these, plus I have some extra. So I'm going to need 6 of them. 2, 4, 6, 8, 12. 2, oops, a little off. 2, 4, 6, 8, 12. Line 2, 4, 6, 8, 12. And I know 1, 2, 3, 4, 5, 6 times 2. And I know I need more than 5, one more than 5, because they told me I have 5 full ones. Because that's what that 5 right there means. 2, 4, 6, 8, 12. And my last one, 2, 4, 6, 8, 12. All right, so these are all full. 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 But now I'm not going to fill all these. I'm going to fill 7. So 2, 4, 6, 7 of them are full now. So this shows this. So you do the same thing over here with eighths after you divide 8 into. Remember, your answer, you're going to have a whole number here. That'll be a whole number by itself. And then you're going to have a fraction right here. Okay? It's going to be over eighths. So a whole number there, then your remainder right here. Look on the back. I'm going to read this one. I'm not doing it for you. Shen is ordering meals for a picnic for 3 local schools. He wants to estimate the number of meals to order. Shen needs meals for 124 students from East Elementary School, 178 students from North Elementary School, and 206 students from Central Elementary School. Okay? Shen estimates the total number of meals for all 3 schools by rounding each number to the nearest 100. So round these to the nearest 100. Shen thinks he estimated correctly. What is the actual total number? So then add those 3 numbers. Will Shen's estimate give enough meals? Using Shen's estimate, will they have enough? Remember, this is the number you really need. Is the estimate going to give you enough meals? To make sure Shen orders enough meals, what strategy can he use to estimate? So if this is wrong, how should he have rounded? By tens, hundreds, by ones? Figure that one out. Write it all down, work out. This one's going to take you some time. You might want to rewind and listen to me read it again. I was reading it a bit fast. I apologize. But, all right. Estimate rounding to the nearest 100. These 3 numbers added together. Actually add these 3 numbers up right here. Is the estimate bigger than the actual number? Because if it's smaller than the real answer, he does not have enough meals. And you can maybe say how he should have rounded it to figure it out. By hundreds, ones, tens, thousands. What did he need to do? All right. I hope this helps. And as always, have a good